all the same, isn't it?
Also, I think Tori is jealous of your hair aerodynamics.
He is.
Totes.
It was talked about this week.
Quite a bit, more than I expected it to be.
Yes.
Let's see here. What was I doing? Oh.
Whoever knows whatever you're doing.
So are we getting
Sure.
a feed from Twitch and you and our chat room?
Yeah, we're
in here.
We're going to.
It's all together.
It's all together.
All together now.
All together.
Thank you. Somebody knows a biggest preference.
Did you go live on all of the things?
I did.
All of the things.
Oh yeah, you did.
We are live on all the things, except I forgot to do the presets for the new stuff.
That's going to be fun for you.
Hi, Lars.
Oh.
Hello, Internet.
Because the groups don't group.
The groups don't group. What are you talking about?
The groups don't group.
I don't understand what you mean.
Ni entiendo.
I've got a group for news.
Oh yeah, you can't subgroup.
Right. The groups don't group.
Yep.
That's it.
He did say that.
But you can color code your groups. You can color code the groups, so you could actually make all the groups that are news in their own color, and then all the groups that are something else in something other color. We are 4 minutes away. L minus 4 minutes.
Oh boy.
Ah, jeez.
Oh
Holy
goodness. I'm just gonna do the show from over here today.
Ah, jeez.
Oh, jeez.
So for those of you watching live, we are running a test on twitch.tv. If you'd like to participate in the test, you can head on over to twitch.tv/TMRO-TV. We don't have the ability to do a 4-letter username just yet. We've asked for some help on that. No idea if it will actually work, right? So the official stuff is still on the YouTube side.
It's a crouching kitty, hidden Jared.
Nice. It's true. Chris Radcliffe, that is very true.
And one of the other neat things about Twitch, if this works, big if, we are sucking the chat room out of Twitch and dropping it into a different room in our doohickey, our moderated tools. So
Tools?
we should be able to see what you say there, and that can get pushed to our hosts channel, which is, how neat is that? It's pretty neat.
That's pretty neat.
Everyone's saying that audio's out of sync.
Audio out of sync. I'm not sure how to fix an audio out of sync. Audio's out of sync where? How's that?
Yeah, now we got 3 streams. We need to know a little more data.
Audio's out of sync where? How's that?
Yeah, now we got 3 streams. We need to know a little more. Feel like I just-
Time dilation!
For Keep says
YouTube.
YouTube. Aspen says YouTube.
Don't know how to fix that. Is it only out of sync on YouTube?
Chris Radcliffe also says YouTube. Seki says YouTube.
All right. So what happens on? Is it out of
Twitch
sync?
and YouTube.
Twitch and YouTube. That's not good. Okay.
Oh, now Twitch is apparently in sync.
So, here's the deal. We're 1 minute away from launch. I have the option of restarting the encoder, but that's going to make us start late, and it's going to drop everyone's connection, and there's no guarantee that everything is going to come back nice and neat. Or, and this is what I would recommend, y'all live with a slightly out of sync live show, and we'll fix it in post. The other thing is, if you go here, I'm typing this into the chat room. It sounds like, pun intended, that one might be in sync. So if that's the case, the twitch.tv/TMRO-TV. If that's in sync, then give that a shot. See if that's any better.
By the way, hi Twitch.
And hello, JVal90, BR Spies, and Bernie's on... oh, it's off on Twitch and YouTube.
Oh no, Twitch is
No,
fine.
people are saying.
yes, only YouTube. Okay, copy. Well, I was looking at the Twitch chat.
All right.
Yeah, Twitch is fine. Rebecca says it's fine.
Levi, I don't know how they've decided to do the rollout, so sure.
All right, let's go ahead and start this show. You guys ready?
No.
Oh, sorry, not ready. Hold. Let's recycle the clock to T-minus 13 seconds. Actually, that's a good question. So what is the closest clock recycle you can get? It's
With
Atlas-
shuttle, it's 31 seconds.
Yeah. Oh, well, that was
Right?
31 seconds off the book, I thought. On the book,
okay.
you're supposed to go back to like 9 minutes or something like that.
Oh, well,
4 minutes?
4 minutes.
Was that it?
Sounds about right. I've just seen it with
But
shuttle
I
before.
thought Atlas could. Yeah, no, that's definitely a thing I've seen too. But I'm pretty sure they're
Yeah.
like, Windows closing, keys to on, ready go. I think that's how I envisioned that going on at the Launch Control Center.
Did you
Atlas
see?
is-
Yeah, he did call you Rebecca, didn't he?
Did I say Rebecca? What did I say? Rebecca. Oh no, Rebel. Sorry. Now, what did you do?
Friesland.
Did you save your changes?
Not in the last 5 seconds.
Oh,
It's fine. Just run the show as is. It'll be fine.
why is my microphone?
Run the show as is, he said. It'll be fine.
My microphone's all messed up.
All right, so I'm going to tell Core to restart YouTube only. So we'll leave Twitch and Facebook up. So if you're on YouTube, there's a possibility this will not come back. Give me a moment. We're doing upgrades to Hollow Mic. No, I mean. All right, so here, goodbye, YouTube.
Bye.
All right, YouTube's back up. It's going to take them another while. YouTube.com/TMRO. Don't cross the streams. It's funny. You're funny. Goodbye, YouTube. YouTube's back up. While. YouTube.com/TMRO. Don't cross the stream.
YouTube is better.
YouTube's fixed? Huzzah! No, don't. Okay. There's going to be audio delay because the switcher adds 1 frame of delay. At our frame rate, that's a little over 30 milliseconds. You're going to see it when you clap. Stop it.
They asked to clap.
He said, "Clap my hands," and I deliver to the
Just
people.
clap your hands. Just clap your
Clap your
hands.
Clap your hands.
Alright, are we ready?
Yeah, oh yeah, we are very ready.
Are you sure?
I don't know.
I don't feel ready.
Me neither.
I haven't had enough coffee.
Welcome to Orbit 10, Episode 10 of Tomorrow. I'm Carrie, and with me, as always, is Benjamin and Jared. Although, I guess not always. I shouldn't always say that. And Dutta. Dutta I always have. I always have Dutta. Oh, my goodness. So many things going on. First and foremost, we definitely want to make sure we give a huge shout out to our Patreon members. These are the people of the Escape Velocity variety. These people have given us $10 or more for this particular segment of this particular episode. And without them, most of this stuff would not be possible. So thank you for that. If you would like to become a patron, please head over to patreon.com/TMRO. And major announcement. Are you ready?
Yes.
I don't know. Should I be sitting for this?
Probably.
All right.
Good boy. Daylight saving, particularly if you live here in the United States of America, it's coming, and there's just nothing we can do about it at this moment in
Like
time.
winter is coming.
That's how it feels anyway. So the thing to note, though, is that this show always only adheres to UTC. So we will always be at 1800 UTC, which means for those of you who change your clocks, that means the show is also shifting ever so slightly. It is spring forward, so be aware of that. So maybe somebody will be awake to watch our show. So
If you change your clocks, it'll be an hour later for
Yeah.
you. If you don't change your clocks, because about half the world doesn't, if you don't change your clocks, the show's at the exact same time. So
Yes.
change your clocks whenever that may be, because not everyone changes their clock at the same time.
Right.
If you go into daylight saving, Show becomes an hour later for you, starting after you change your clock. For everyone else, no changes to you whatsoever. And we get to do that twice a year, and it's fun every time. All right.
Yes.
Yay! All right.
Whoop-de-doo.
Can we go move on to just something interesting?
Oh, yeah.
Space related, because that's just too landlocked for me, if you will. See what I did there? Based on trains and just wiki it. Okay, so Ben, we have a launch, right?
We had a Sentinel-2B launch via a Vega rocket. Here's that footage. And right off the pad,
So long.
whoosh!
So awesome.
That's solids. That happened Tuesday, March 7th, 2017 at 01:49 Coordinated Universal Time. Vega debuted its first flight in 2012, and that was 9 out of 9 successful flights for Vega, so congratulations. Sentinel-2B is an Earth observation satellite. It's going to join its identical twin satellite, which was, I believe, Vega 2A, that launched in June 2015, and this is for the European Commission's Copernicus program, which sounds like some sort of evil villain's like laser space, right? Activate Copernicus. It's a multi-billion-dollar network that will eventually consist of at least 15 spacecraft scanning the planet with radar, optical, infrared, and microwave, as well as laser instrumentation. It's going to keep track of Earth changes in land surfaces, oceans, ice sheets, and atmospheres. Sentinel-2B, of those 15 satellites, is the 5th Copernicus satellite to launch since its deployments began in 2014, and it will be fully operational in 3 or 4 months. And as I'm going to talk about later, it's good that the European Union is working on Earth observation because the United States may not be doing that much anymore. So
Yeah.
we'll get to that in a moment.
All right. And you said that was solids, right?
Yeah. Oh, yeah. Vega is a solid first stage solids. So that's why it just kind of goes boosh right off the
Solids.
bat. It's also why, because Ariane Space normally cuts to this really awesome camera of it's the Vulcan engine, right?
Yeah.
Vulcan, yeah. They cut this really great shot of it starting up, but with a solid, there's no really, there's not a startup sequence. It just goes.
Detonation.
So, yes, exactly.
goes.
Yep. So there's no point to go to the engine starting the startup sequence because off it goes.
Solid propellant.
Well,
All right.
are you giggling at the chat room?
No, I was giggling at solid propellant.
Solid propellant.
Because it goes.
As opposed to liquid. I figured
All right.
it's one of those things we haven't gone over in a while, and I thought any new users may not be as familiar. So there. All right. So, Jared, on the, by the way, fantastic interview.
Thank
with
you.
Mr. Tori Bruno.
Yeah.
That was incredible.
That was the highlight of my life so far.
That was really,
One of
really,
the highlights.
really amazing.
So, yeah.
And not that this is ULA news per se, but you've got some Blue Origin news.
Yes,
which,
Blue Origin actually saying something for once.
Yeah.
Now, the new details this week have actually come out, not only about Blue Origin's New Glenn launch vehicle, but also about the BE-4 engine that they're working on. Now, a new animation is showing the two-stage variant of the New Glenn vehicle. It's going to be standing 270 feet tall, and oh man, that is just a really, really big rocket. Now, it can lift 13 metric tons to geosynchronous
That's
orbit.
so cool looking with the legs.
Yeah, I like the
does,
landing
yeah.
legs. They just pop out. It's got little finsies, too. Look at the
Little, that's what they refer to them inside of Blue, is the little finsies.
finsies.
No, they don't.
And it can actually lift 45 metric tons to low Earth orbit, so quite a bit. Now, that first stage uses 7 BE-4 engines, each of those engines putting out about 550,000 pounds of thrust. So in total, you get roughly about 3.85 million pounds of thrust on liftoff with the first stage. So that's pretty impressive. Second stage continues on. You can even get a third stage, which then puts the vehicle up to 313 feet tall. So in other words, that's one big rocket. And of course,
huge.
Reusability is all the rage these days. All the cool kids are doing it. So the first stage will be reusable, and in the animation, as you can see here, it lands on a barge. Where have
That's
you seen-
moving.
Yes,
yeah,
that's
but
moving.
different. That barge is moving.
Yeah, because why have a barge not moving when you can move your barge?
Well, no, that could be advantageous potentially, right? If there's a gust of wind, move with the wind.
Yeah, that's true.
Right.
You
Yeah.
could do that. So, reusable first stage, very, very cool. And then, if that wasn't enough for you from the awesome Blue Origin people this week, they decided, you know what? Why do just one thing this week? Let's show off a fully assembled BE-4 engine as well. So this is one of the
looks
BE-4
incredible,
engines.
not gonna lie.
This is their first fully assembled BE-4, and it is a Methalox engine. So it's actually going, yeah.
That's Methalox, yeah.
Yeah, Methalox. It's going to be using methane and liquid oxygen together there to generate, as we said, 550,000 pounds of thrust. Also staged combustion as well, which is a little bit better than, or I guess a little bit nicer, if you will, than other forms of combustion that you can do with a rocket engine.
Could be potentially more efficient. It's just kind of harder to do.
Yes, that's a good way to put it.
Yep.
Now, also some news this week from them as well. Eutelsat has been announced as the first customer that will be taking a flight on New Glenn sometime in 2021. And in addition to that, OneWeb, the company that's going to have 900 satellites providing internet in low Earth orbit, has also announced that they are going to be a customer on New Glenn as well. So not only do we have the initial parts of the rocket being built, now we have customers for Blue Origin's rocket as well. So very cool stuff happening this week.
Very nice. That's really, really cool. And I also, it's one of those things where, again, somebody, I think in the main chat room said something along the lines of like, oh, still a great coffee table, right, Carrie Ann? One of those famous comments I will never ever live down. But it is kind of funny how I don't have a good concept of how big some of these engines are until I get a human right next to it, and I go, oh,
that's a big engine.
Now I understand.
I think it would even look larger if they made it go vertical as opposed to horizontal.
Yeah, totally. But when you see like 6 or 8 guys like all the way down here, and the engine's this.
They did take a picture of it in the vertical, but it doesn't have that to scale, people for scale. Kind of banana for scale kind of look with it.
Right.
So.
That's approaching F1 size, isn't it?
Yeah, it's pretty good size.
F1 being the engine on the Saturn V.
Yes.
Thank
the
you.
first stage of the Saturn V.
It speaks.
Thank you, Dada.
We need like a bing. Okay, so Benjamin, speaking of NASA-y things.
All right, NASA has passed, or not NASA, the House has passed NASA's, oh, this is going to be an interesting show for me, authorization bill for 2017. It's the first time since 2010 that both the House and Senate have passed an act like first time. So this has been a long time since this happened. We have a little bit of footage from the floor.
Mr. Speaker, I rise today in support of the National Aeronautics and Space Administration Transition Authorization Act of 2017. This bipartisan and bicameral bill grew to maturity through many long and serious discussions about the future of our nation's space program.
Now, as I mentioned, the bill did pass the Senate by a unanimous consent on February 17th. We then went to the House and it passed on March 7th. It's going to authorize $19.5 billion in spending for fiscal year 2017 for NASA. It has a detailed plan for NASA's human exploration programs with a long-term goal of sending humans to Mars. So a slight shift, right? We kind of went moon, Mars, everything else. So this bill is basically saying, you guys, you're going to Mars, figure it out. NASA is giving NASA the ability to establish long-term medical monitoring of former astronauts, which will also be interesting for determining what space does on the human body, long-term, even when you come back to a 1G atmosphere. It's also directing NASA to study the use of Orion spacecraft for going to the International Space Station. The idea being if the commercial partners continue to slip to the right on the timelines, maybe we can use Orion to make that go, as opposed to the other project, which is like hanging a nail. What am I trying to say? Hanging a picture with a sledgehammer a little bit. I mean, that's right. That's like a deep space spacecraft. Sending it to low Earth orbit would be kind of
silly.
Sad. But as I mentioned earlier, the bill does not address Earth sciences at all. Now, it doesn't say no to Earth sciences, but it also doesn't refund any of them either. Yes. So they kind of need money, which is not necessarily a good thing. Now, basically the argument is NASA shouldn't be doing Earth sciences. Entities like NOAA should be doing Earth sciences.
Right.
And everyone else is like, but NASA does the satellite stuff. This is going to be an interesting debate because Earth sciences are incredibly important. It's not one or the other. It's not human exploration or Earth sciences. Right. It's not human exploration or robotic. It's all of them. All of these things are important equally. And this particular bill puts a huge emphasis on human exploration at the cost of absolutely everything else. So we will see how that ends up being in the long term, but that's basically what NASA fiscal year 2017 is shaping up to be.
Yes. So
there you go.
Yowza.
Yowza.
Yeah.
But, human exploration is not bad, right? It's the thing that inspires people. I'm not saying human exploration is bad. I'm just saying that all of it's important. So
Yeah.
you can't have one at the cost of these other things.
Yeah.
Did you say
That's true.
exploration both times, or did you say expiration one of those?
I meant to say
times?
exploration, but it's possible I said
I mean, dead humans, not a big deal, but human exploration.
Dead planet, not a
should
big
definitely
deal.
get out
Elation.
there.
exploration. Great, now I'm just questioning myself. Move on, move on.
Oh my goodness. All right, Jared, save us from this.
Yes, I want to talk a little bit about hydrogen.
Okay.
The most abundant element in the universe, because hydrogen's really fun. You can fill zeppelins with it. Well, maybe don't do that. But there are
It is really fun.
There are a multitude of things that hydrogen does for us. And a new study from Cornell's Carl Sagan Institute has found that greenhouse gases can increase the size of a star's habitable zone. So what does that mean? That means if an atmosphere of an exoplanet is made out of, say, carbon dioxide, or in what they were specifically looking at in this study, hydrogen, which captures a little bit of the energy from the light and energy that a star is giving off, that you can actually have a habitable zone out further than you would regularly. So it extends the size of the habitable zone. So instead of maybe a little narrow band, it may actually increase the size of it. Now,
Okay, so like for instance,
Yes.
we have our star that we call the sun.
Yes.
Right? And our habitable zone is pretty much right where Earth is.
yeah, it kind of goes from a little bit around Venus out to a little bit around Mars.
Okay, but
So
that's
the general area.
That's a booted, what
Yes.
some people have been calling like the Goldilocks zone.
Yeah,
right?
the Goldilocks zone is a good way to
I feel like Venus is
Okay.
not super habitable, but okay.
Yeah,
But
well, it's
that's
not.
More, that's more,
I feel like they extended that bar a little far. But okay.
That's no fault of Venus. It's the fault of its atmosphere.
All right.
right. I was gonna say that's but where Venus is
Sure.
is
Yeah.
in that. It's just Venus is. Whatever. We'll get to that later
Yes.
in a different thing. Okay, so everyone's really excited about the TRAPPIST one.
TRAPPIST-1.
TRAPPIST
Yeah.
one. Okay, and all of those planets and exoplanets is what we're calling those, right?
Yes.
And there's 7 of them that were in the Goldilocks zone. Is
There were
that
3 of them
Okay.
out of those 7 that are
Okay.
in the Goldilocks zone.
So are we saying that we know for sure that Goldilocks zone is only those 3, or are we saying that there's a possibility that it could actually encompass more than that?
This new study says that if you have the right kind of atmosphere made out of the right kind of gases, you could actually extend out that Goldilocks zone.
Okay.
You could make it bigger than it should be just with like an Earth-like atmosphere.
Gotcha.
So if you have carbon,
Okay.
actually they did a modeling of it in our own solar system.
Mm-hmm.
And if you had a carbon dioxide atmosphere, you could actually have a planet in a Goldilocks zone all the way out to the asteroid belt. So
Interesting.
far beyond where Mars is at.
Right.
And one of the reasons that they were looking at this is because they wanted to look specifically at hydrogen, which comes out of, on most places that we find in the solar system where we find hydrogen, it would come volcanically. So one of the places was Io, which is one of the moons of Jupiter that we were showing off earlier. And those volcanic plumes send out sulfur and hydrogen. And we actually have some really cool video footage, or a nice little animated picture of a volcano erupting on Io. So
That's incredible.
So this was taken by New Horizons back in 2007 when it flew past Jupiter. So so they've realized that you can actually have different atmospheres, and these different atmospheres lead to different Goldilocks zones. So it may not just be what we want to find with a nitrogen and oxygen atmosphere here on Earth that may work for life. You could find these very weird atmospheres made out of hydrogen or carbon dioxide, and that may actually allow you to have the potential for life in places that otherwise you really shouldn't be able to have that potential for life.
Interesting.
So, very interesting result. And of course, they're hoping to use the James Webb Space Telescope once it launches in late 2018 to
You meant to
actually
say
determine.
when it launches in.
Well, it will hopefully launch in 2018.
Yeah, it's going to launch.
Yeah, with as much as it's costed, the telescope that ate the budget, it should.
Only about 6 months away. It's fine.
Yeah, it's 6 months. Just 6 months. So, very cool study that happened.
That is-
they got
yeah,
a
that
very
is really
interesting
cool.
result out of that.
All right, you're going to keep us updated on that, right?
I will keep you updated on
Awesome,
that.
because
Yes.
all right. I like learning those things. Sorry. I realized I just totally hijacked that entire segment there for a
No,
second.
that's fine.
Okay, so, Benjamin,
Carry on.
you have more landy things to talk to us about.
More landy thing.
Well, I mean,
Landy things.
orbital ATK.
Yeah. So more rockety things.
that
This
works.
is the year of trying to build rockets. Apparently, it's all the rage. Orbital ATK is expecting a decision on their new rocket, a go-no-go decision, by early next year. Here's a picture of their Liberty rocket, which is what the new rocket is loosely based on. The new rocket's really only known as the Next Generation Launcher. It's an Air Force-funded program to develop a new launch vehicle, and it would be capable of carrying intermediate or large payloads. Much like the Liberty rocket there, the first stage is based on a solid motor from the Space Shuttle. Now, all the articles I said, it says it's based on the Space Shuttle solid motor. I actually believe it is based on the SLS solid motor, which is a 5-segment solid motor as opposed to a 4-segment solid motor, has a little bit more oomph. And this is, we've actually got some test footage of what that looks like. This is about a year old. It starts off in slow-mo, and then you're going to get, I know, isn't that amazing? Yeah, there you go. In addition,
Thank you, Jared, for that audio.
oh no, audio will come. There it is. Oh well, it's really low. I made it too low in the clip.
Also,
yeah, there it is. A little bit of audio.
It's kind of peaking a little bit.
Yeah. It's just all across the spectrum.
Blew out the microphone.
The thing with this is that in addition to the solid center core, they can also have the option of solid strap-on motors. So you could have a 3-segment solid motor lifting off into space, which would be all sorts of incredible. It also has a liquid oxygen, liquid hydrogen, so a Hydrolox upper stage, with using a version of Blue's BE3 engine, which is the current engine they're flying on New Shepard, as opposed to the BE4 engine that Jared was talking about earlier, which is a Methalox engine that'll be flying on New Glenn. The BE3 engine is also going to be the upper stage of, they're basically taking New Shepard and dropping it on top of, I believe they're taking New Shepard, dropping it on top of New Glenn, or they have the option to do that for another stage. If the Air Force elects to not continue with the program, basically they're paying upwards of like 60-70% of this thing. If they choose not to continue with the program, it's like the orbital ATK will scale back its work on the vehicle. So not quite what we're used to with the new space companies, where like Sierra Nevada was like, you know what, you guys didn't pick us, but we're still going to put our money into it.
Right.
We're still going to make this thing happen. Same thing with all the other, like Blue Origin, just kind of doing it on their own, making that stuff happen. Slightly old space mentality on that, but having more launchers and having more competition is not necessarily a bad thing.
Yeah, it's all good.
Yeah.
All right, Jared. I'm probably gonna have more questions about this one too. Tell me, because I keep Goes 16, which reminds me of Gozer, which isn't called Gozer anymore.
Yeah, it's not called Goes-R anymore. It's
Yes.
called Goes 16.
Okay, so that is the
I'm
same.
sorry,
kind
but
of
that's
thing?
what the National Oceanic and Atmospheric Administration does. They just rename things once they get to orbit. So.
Yeah, we do that with
I
planets.
mean, NASA does that with TDRS as well.
Good
Do
call.
they rename TDRS satellites?
Yeah, don't they? They changed them from like TDRS M to TDRS 8 or something.
Oh,
like
well,
that.
maybe. I don't know.
Yeah, they kind of do the same thing,
Yeah,
if
yeah.
I remember correctly. So,
Maybe.
but yeah, there's a really cool instrument on board of GOES 16 that
Yes, thank you.
actually maps lightning. And
What?
we got it maps lightning. So
Okay.
it looks at lightning, and we got back the first real-time footage of lightning from this mapping instrument.
That's pretty. I want
That's
a
what it
live,
looks like.
I want like a live stream of that.
That's so
Yeah.
cool.
So what's neat about this is that we're looking at real-time lightning strikes from a severe thunderstorm over Texas. And that's what the lightning is doing. And what's so cool about this is that GOES 16 is the first satellite in geosynchronous orbit to carry an instrument like this. And it's not just looking at this part of the world with its mapping instrument. That lightning instrument looks at the entire disk of the Earth. So, like, one whole side of the Earth is being mapped in real time for lightning strikes. And this mapping of lightning can help forecasters better predict severe weather, and they can also allow access to this data within 20 seconds of the data being taken. So, very fast turnaround time with that. So,
We're all fascinated by it. We're stunned by the
yeah,
footage.
everybody's
Yeah,
just kind of
well,
taking a look at it.
Well, because I'm also trying to figure out, like, there's the green.
Yeah, what is the green? Is that just
Line?
like
The green is the coastline.
So
So
we're
above
looking at-
That makes way more
above
sense.
that
now.
is Texas, and
Right.
then below that is the Gulf of Mexico.
Okay, but
So-
the storm encompasses. That's so
Yeah.
interesting.
That was really cool that they've
Yeah.
got that instrument now up and running. So
That's really, really cool. Oh my goodness. Okay. Yeah, all right. So we need a break because that was just like, that was a lot, right? Okay.
Okay.
So, good. That was really cool. I'm going to go back and watch that again during our break. So we're going to take a break at the moment. And when we come back, we've got a really great interview, actually, with Dr. Anita Sengupta from JPL's Cold Atom Lab, or CALB. CALB? Is that what we're...
Cal.
Cal. Good old Cal, as it were. Stay with us. We'll be right back.
Look into her face, determination in her eyes. She won't give up a question.
welcome back to Tomorrow. Now, before we get started with our interview, I wanted to give a huge thank you to all of the patrons of Tomorrow who've helped to make this specific segment happen. These are people in the Escape Velocity tier. They've contributed $10 or more to this specific episode. We've also got our Orbital tier. These are people who've contributed $5 or more to this specific episode. If you'd like to find out how you can help these shows continue to survive and thrive, head on over to patreon.com/TMRO. All right, we've got an incredible interview with Anita coming up, but before we do that, I wanted to give you guys a really quick intro video as to what the Cold Atom Laboratory is.
There are many things that we actually don't understand about matter. One thing, for example, would be gravity. We know that gravity exists, we can observe gravity, but people don't understand the particle nature of gravity.
Roughly 68% of the universe is dark energy. About 27% makes up dark matter. So all we know is less than 5%. 95% of what surrounds us continues to be a mystery.
What we're trying to do is to understand the fundamental nature of matter by basically continuing the quest to get to colder and colder temperatures.
It's not just lower temperatures, but it's also the fact that we want to study atoms, and we want to look at them for really long periods of time. And that is really only possible in microgravity.
We're going to be getting to a temperature regime which no one has ever seen before. So it's essentially the unknown what we're going to find in terms of how matter is going to behave at those temperatures.
The Cold Atom Laboratory is a journey to try to understand and to explore the unknown.
All right, we're joined now by Anita Sengupta, who is the project manager of the Cold Atom Laboratory, also has a PhD in aerospace and mechanical engineering, and going back to the Mars Science Laboratory, was a lead system engineer, that team that developed the supersonic parachute, allowing Curiosity to land. So Anita, thank you very much for taking time out of your Saturday and joining us today.
Thank you for having me.
So let's get started with the Cold Atom Laboratory. We have the intro video kind of talking about what you're doing. You're creating essentially the coldest place in the known universe, and you're sending that up. It'll be up on the International Space Station. But why? Why do we need to create something super, super cold?
So the purpose of the Cold Atom Laboratory mission is essentially fundamental physics, is to understand some of the fundamental physics or nature of matter. And so if you think about phase transitions that everyone is aware of, so think of a gas, a liquid, and a solid. Think of how different it is when you go from a gas to a liquid and when you go from a liquid to a solid. So the physics of the matter actually changes when you go through these phase transitions. And so what we're doing is creating yet another state of matter, which is called a Bose-Einstein condensate. So when you have a very dilute, low-density gas and you chill it down below a certain temperature, it experiences a phase transition, similar to a gas going to a liquid. But when it experiences this phase transition to a Bose-Einstein condensate, it behaves completely differently. All of the atoms, which typically behave as sort of random billiard balls smacking into each other, all occupy the same quantum state, and they behave almost in unison, like dancers in a chorus line, which gives a whole bunch of fascinating properties, like superfluidity, for example, where things are now very ordered as opposed to random.
So, and what is superfluidity? I mean, you said it's ordered, but what does that look like, or what does that entail?
So one way to imagine what a superfluid is like, which, by the way, you can create with helium-3, for example, is if you had a cup of superfluid, like a coffee cup, and you put your finger in it and you spun it around, it would spin around forever because there would be no viscous losses in that liquid. And so that only happens when the atoms take on this ordered state, when they get below this condensate temperature.
One of the other advantages, as I understand it, is you mentioned no losses. You could also create something like a superconductor with atoms in this state, which would be a very like a lossless energy transfer system. Is that expected? I mean, do we know that that's what's going to happen here, or is that part of the experiment to see, can we create superfluidity? Can we create superconductors?
It's more to understand the fundamental physics behind what happens when you get to these states. And then when you understand the fundamental physics behind it, you're able to develop theories and equations. And then in the future, you can potentially harness it for technology applications. So you first have to understand the physics. And then once you understand the physics, you can down the line harness it for technology applications.
Warp 11 in the chat room, Max, is asking, what temperature are we talking about here? I mean, how many degrees Kelvin are you trying to get down to?
So it's incredibly cold. It's basically just above absolute zero. So if we think about a very cold thing that we're familiar with, the temperature of space is roughly between 2 and 3 degrees Kelvin. We're going to be at 100 times 10 to the minus 12 Kelvin. So that's about, a billionth of a degree above absolute zero.
And technically, absolute zero is not possible, right? Because you'd have to extract an infinite amount of heat out of a thing. Just like reaching light speed's not possible, you can never quite get there. You can't actually make it to absolute zeros. And this will be the closest we've ever been able to go, correct?
That's correct. Yeah. So you can never become. So what temperature actually is a measure of motion, is a measure of speed. So when you make something, when you cool something down, you actually slow it down. And so if you were truly able to get something down to absolute zero, it would completely stop. And that can't actually happen.
And then what are we actually making super cold up on the lab? I mean, there's got to be a gas or something that we're cooling down.
So we're looking at two different isotopes. We're looking at rubidium-87 and potassium-39, and we're also looking at potassium-41. But in terms of the two different atomic species, we're looking at rubidium and potassium. And we're going to be cooling them both down to their Bose-Einstein condensate temperature and below.
This question comes from Heldesk, which is, how mature as opposed to bleeding edge and new of a cold lab are we talking about for something suitable and operating on the space station as opposed to like a terrestrial lab running down here? Because we have labs down here that are making super cold things as well.
So the reason why we're going to be taking our facility up to the International Space Station is because it's in a microgravity environment. When you use the techniques that we use to cool atoms to these really cold temperatures in Earth-based laboratories, you can only cool them so low, and you can only observe them for really short periods of time. When you get to a microgravity environment that you have on the International Space Station, you can get orders of magnitude colder, and you can also watch them evolve over periods of seconds. So you get a lot more science. You understand the transient behavior of how the Bose-Einstein condensate behaves.
So you're talking
That's
about, you're getting milliseconds here on Earth as opposed to many, how many seconds? Are you talking like 5 seconds, 20 seconds?
So in principle, depending upon the size of your facility, you could go for minutes. But in case of our facility, because of how big it is, we can go for on the order of 5 to 10 seconds.
And is this just the
Which
first?
is still orders of magnitude improvement over what you can do in Earth-based laboratories.
And actually, that brings up another interesting question. It is sized smaller, right? Because it has to go up to space station, which means you need to launch it up there. You have size and weight constraints. So, did that put limitations on the monitoring equipment that you could have as well, like any sort of sensors or cameras or anything else that you're putting on the cold lab?
It certainly did. So if you have a payload which is going inside the International Space Station, you go in something called an express rack. It's a standardized payload interface. And so it defines the maximum volume that you can possibly be. And so our instrument, the heart of the instrument, which you can kind of see in the graphic there over towards the right, is a vacuum system. It's actually a glass vacuum system. To be able to create the Bose-Einstein condensate, or BEC for short, for the acronym, you have to basically get rid of all the atoms that you don't want. So you're in a super, super ultra high vacuum state, and you only put into it the atoms that you do want, which in our case is rubidium and potassium. So our size of our vacuum system somewhat limits the amount of time that we can watch these things evolve, because eventually as the gas expands, as it cools, it will basically hit into the side of the vacuum chamber. Obviously that doesn't do anything bad, but then the experiment is over. But the advantage of our system is that we can run a new experiment roughly every 10 seconds. So we can generate a lot of science data for many years.
And then moving forward, is there a future commercial application? This comes from Green Jim too in the chat room. Future commercial application for orbital sub 1 Kelvin cooling?
So there's many different aspects to the CAL mission and the technologies which are used. The primary method of cooling, which we can talk about a little bit, is laser cooling. And laser cooling brings you to pretty cold temperatures, roughly micro Kelvin temperatures. And so when you get atoms down to these states, you can actually use them for atomic clocks. And so atomic clocks have purposes for timing for basically navigation in space. So that's one very obvious technology application for both NASA type missions, ESA type missions, as well as commercial type missions, is more precision in your navigation. The little cloud that we create, which is the ultra cold quantum gas cloud, the Bose-Einstein condensate, is also incredibly sensitive to fields. It's sensitive to gravitational fields, electric fields, and magnetic fields, which means by watching the motion of the cloud, you essentially have a sensor. So you have a quantum sensor, which can tell you information about gravity, magnetism, and electric fields. And so it also has a future purpose of being a sensor. You can use that sensor once again for navigation, or you can use it for science purposes, such as trying to understand the gravity variations around Europa, for example.
And actually, that was one of the things that was brought up in the video, which is help us understand gravity. Because I mean, we know gravity exists. If I drop my computer, it's going to fall. That's gravity. But what will this experiment help us understand about gravity and its makeup and what creates gravity?
So one thing which I think probably the general public doesn't know, understand too well, probably is quantum mechanics or atomic physics. And so atomic physics is the study of single particles interacting. And when you get down to those atomic scales and those subatomic scales, the gravitational force is actually incredibly weak. It's about 6 orders of magnitude less than the other forces associated with the atom. And so what we don't really have is a correlation between gravity, which we certainly all understand in terms of, how the sun and the moon and the earth interact with each other, yet when you get down to the atomic and the subatomic scales, gravity doesn't even come into the equation. So the theory of quantum mechanics right now is not coupled to the theory of gravity. So we don't have a way to tie those things together. And so part of what this experiment is going to do is try to understand how complexity arises in the universe from the subatomic scale by creating macromolecules, which we call Feshbach molecules, to then see how they interact with each other and hopefully to scale up that physics to how we see large systems interact, such as the sun, the moon, and the earth. And we have another technique on board the facility, which is called atom interferometry, which is similar to a light interferometer, but instead of looking at light packets, we actually look at atom packets. And we're going to do basically Galileo's famous experiment where he dropped 2 balls of different masses off the top of the Leaning Tower of Pisa, and he watched them fall, and they hit the ground at the same time. So we're actually going to do that with atom packets. And instead of just falling the distance of the Leaning Tower of Pisa, we're going to fall the distance of many, many miles as the International Space Station traverses its orbit around the Earth. So we'll get a much more precise measurement of the gravitational equivalence principle test.
And then kind of taking that forward, kind of trying to figure out gravity. Hypothetically, Rebel is asking, would dark matter maybe be also hypercold so we can't see it? So would this kind of allow us to look at maybe dark matter or anything in that realm?
So the CAL instrument in the current configuration is not set up to be a dark matter detection instrument, but the technologies that we are developing and demonstrating in space can be used in future, which is essentially laser cooling, creating a Bose-Einstein condensate. That being said, one of our investigation teams is actually going to look for the presence of chameleon fields. Chameleon fields, if you can show that they do exist, is then tied into dark energy.
So what is a chameleon field?
So it's an interesting way of thinking about it, but there's a belief that dark matter, dark energy actually has a gravitational distribution on the surface as opposed to the interior. And so by taking a look at how the 2 Bose-Einstein condensates interact with each other or how they interact with the wall of the chamber, we are hoping to detect the presence of one of these chameleon fields.
Then from the chat room, Psyche, not sure how to pronounce that one, asks, what about the opposite state? Are they likely to exist at all, like something from the Big Bang? You're looking at super cold. Is there any plans to look at super hot as well?
So our experiment is just looking at how Bose-Einstein condensates evolve, but one interesting theory from a cosmological perspective is that thermodynamically, the way a BEC expands may be related to how the universe first expanded when it was formed. So when the universe first started, it was the Big Bang, and then it cooled, and as it cooled, galaxies were formed. And so understanding the thermodynamic expansion of a BEC may give us further insight into the thermodynamic expansion of the original state of the universe.
How did you get, this is pretty deep stuff. How did you get here? Because you've been at JPL for a while. You worked on Mars Science Laboratory. So how did you start working on the Cold Atom Laboratory?
So my background actually is originally in plasma physics, and so my doctoral research actually was on improving the ion engines that flew on the Dawn spacecraft. So I do have a background in plasma physics, which is different from atomic physics, right? It doesn't go subatomic; it goes basically looking at ions. Then I moved over to working on Mars Science Laboratory mission, doing entry, descent, and landing systems, and then Venus entry, descent, and landing systems. And then my very, very first job was actually launch vehicles. So I was enjoying your intro. I worked on the Delta IV launch vehicle on the cryogenic propulsion system. So when you work at a place like NASA, when you work at a place like Jet Propulsion Laboratory, you have the opportunity to work on a whole variety of different things. And then for the young people in the audience, the students in the audience, when you study the field of aerospace engineering, it is by definition multidisciplinary. So you have the opportunity to work on these incredibly varied missions, which have almost nothing to do with each other, but you have the skill set, the engineering skill set, which allows you to design systems to be able to give you this great science. So when you work at a place like JPL, you have the opportunity to work on these grand variety of missions if you have the personality where you want to do that.
So I didn't realize you worked on the Delta IV. Were you there when they first lit the Delta IV engine? And if so, what was your reaction when all of that hydrogen burned off around the vehicle? Was that a moment of, oh my gosh? Because you see a Delta IV light and it's just fire absolutely everywhere. It's fine, but there's just fire everywhere. Was that expected? What was going through your mind when you first saw a Delta IV light?
Well, I think the amount of energy which is dissipated is mind-boggling, so you really can't put your mind around it. But it is done in a very controlled and safe fashion. I think it's exciting. So I think propulsion is kind of sort of the basis of aerospace engineering. I mean, being a rocket scientist is kind of what people correlate with aerospace engineering. And I think since then, working on ion propulsion systems is the exact opposite, where instead of having hundreds of thousands of pounds of force, an ion engine only has the force, the weight of a piece of paper. So I've kind of done both sides of things. But I think it's amazing because we understand the physics about how this works. We're able to make calculations to predict the performance, and then we show with the experiments that it works. So for us, it's more about awesome. My calculations matched what the actual performance was. So it's somewhat satisfying.
Is that how you felt with Mars Science Laboratory Curiosity as well? As it's hurtling towards Mars, that was the 7 minutes of terror, I mean, a lot of things had to go right. A lot of things had to go right. If only one thing went wrong, that mission was toast. I mean, what was that like?
So landing on Mars is incredibly difficult, and the reason for that is because you can never test your system end to end until you actually get to landing night. So what you have to do is you have to be super smart. You have to understand all the individual phases of the entry, descent, and landing architecture. You have to understand the fundamental physics behind how each component is going to operate. So my responsibility was understanding the parachute, developing the parachute, testing the parachute. There was a whole other team of people that was focused on the retro rockets, the main landing engines. Another team of people focused on the heat shield. And so each one of those engineering teams took on the responsibility to understand the fundamental physics about how their technology was going to perform, then give you parameters like what the drag coefficient is going to be, what the thrust level is going to be. And then that gets coupled into a Monte Carlo simulation, which then shows you what the end-to-end performance is going to be. But on top of all of that, you've got the Martian atmosphere, you have variations in the Martian atmosphere, variations in wind, temperature, density, all of that has to be captured, and you have to put enough margin into the system so that you don't smack into the ground. So we spend many years of our lives very dedicated to these tasks to fully understand our element, and then we work with systems engineers to link those pieces together and then make sure we have enough margin, and then hopefully it works on landing day. But for us, it's incredibly challenging. It's a very difficult task, but that's what makes it so exciting and fun to work on.
And how do you transition from, it sounds like you've got a lot of propulsion engine background, or at least, something along those lines, right? Parachutes, kind of the same general thing, just opposite direction, over to creating what is the coldest element in the known universe, right? How do you get from there to one to the other?
So that's an ironic thing, because the heart of the Cold Atom Laboratory is actually a vacuum system. So my entire doctoral research was done in vacuum chambers. Not me personally, sitting inside the vacuum chamber, but my engines that I would have to develop, which were ion engines, only operate in vacuum. So I'm very familiar with vacuum systems. I'm very familiar with optical diagnostics, which requires that you understand the atomic transitions of the different species that you're looking for. So I already had all the basic principles from a testing perspective and from understanding at least atomic physics to the level of different spectroscopic lines that you might want to look for xenon, for example, then when you design any engineering system, you break it up into subsystems. And so even an instrument like Cold Atom Laboratory has a mechanical system, has a thermal system, has an electronic system, has flight software. So all of those subsystems, all of the disciplines associated with the subsystems applies to whether or not you're building a spacecraft to orbit Mars, an entry system to land on Mars, or an instrument that's going to go inside the International Space Station. What changes is your environment. So for Cal, it's actually going to be inside of the International Space Station. So our environment from a thermal perspective is actually nowhere near as difficult as the thermal environment that we experience entering the Martian atmosphere, right? Where you're going from the temperature of space, and then 2 seconds later, you're heating up to the temperature of the surface of the sun. So if you understand the principles of thermodynamics, of fluid mechanics, of structures and mechanisms, you can design any engineering system if you put the right team together.
How about, Levi is asking, how about the margin of error in the measurement of temperature itself, right? I mean, there could be an error in the sensors.
Oh, so in terms of, for a Martian entry or for the Cold Atom Laboratory?
For Cold Atom Laboratory.
So Cold Atom Laboratory measures temperature in very different ways. So typically for most of our missions, we measure temperature with thermocouples or thermistors, right? Which is basically looking at two dissimilar metals. There's a voltage between them. That voltage is a function of what the temperature difference is, and then you have a calibration curve and you look at the temperature. So when we look at temperature, we're actually looking at the motion of the atom cloud that we create. And so if the atom cloud is very hot, it actually appears much larger, and we basically generate an image which shows us what a sort of a two-dimensional we use optical density as our measurement, but it's basically an image which shows us this fat-looking cloud in 2 dimensions. If the temperature is much, much colder, we see a much smaller cloud. So we're actually able to develop a calibration curve based off of how big the cloud looks to tell us what the temperature is.
Could we see some sort of application for any of this here on Earth in the distant future based on some of the science you learned from here? Is there anything that someone that isn't interested in space at all may not even realize that some future technology came from this experiment?
So I would say a lot of the direct technology that's come from Cold Atom Laboratory are based on, in-space navigation, in-space sensing of gravitational fields, magnetic fields. So certainly that's a space-based application. There's another really interesting application that we're going to demonstrate on Cal, which is an atom laser. So people are familiar with photon-based lasers where you have a coherent beam of photons. We're going to create an atom laser which has a coherent beam of atoms. And so the first question is, well, what on earth are you going to use an atom laser for? And the people ask the same question when they first created a photon laser. What on earth are you going to use that for? How many things do we use lasers for now, right? Almost everything, from manufacturing to medical imaging. So you first create, you first understand, and then the technology applications follow from there. And that goes for the entire space program.
That's a really great way of looking at it, actually.
And it's true, and most people don't realize that. But you can't know ahead of time what technology you're going to create. But when you understand how the world works, when you understand how the human body works, and all of a sudden things create from there. And that's what engineering is, right? Observation, measurements, that's science. Engineering is the application of these observational measurements.
Is that what excites you most about this particular experiment? What's really got you pumped up about this experiment?
So for me, it was an incredibly difficult challenge because no one has ever built a facility like this. It's probably one of the most complicated science instruments that we've ever built. So I loved having the challenge associated with that. It wasn't my background, so I loved delving into something entirely new. But what we're really doing is we're going to a temperature that no one has ever been to before. We don't know what we're going to see. So it's delving into the unknown, which is what makes it so exciting.
Wait. So you're creating a temperature we've never seen before. Are you going to be able to test this here on Earth, or is the first time you're ever going to turn it on up at station?
So we do have a test bed at JPL where we do basically we created a prototype of the instrument back starting in 2013. So now what we're doing is, or what we've done over the past few years, is take that massive prototype, which basically occupies the size of an entire lab, and then condensed it into something the size of an ice chest. So we are doing, we actually operate the instrument on the ground ahead of time. The problem is we can't get to the exact same conditions that we'll see on space station, which means we can't get to as cold temperatures, because on Earth Earth, we have to face one gravity pulling the atoms down. And on Earth, we have a very different thermal environment. And on Earth, we have a very different magnetic field environment because we're stationary in the same location. So one of the things that we like to say is you always want to test as you fly. But just like on the case of Mars, you can't because on Earth it's different. Same thing for Cal, it's going to be different. But yes, we do run through all of our flight sequences. We do operate our instrument fully from our electronics to our lasers to our vacuum system to test out the full range of capabilities. But there are going to be differences because we're here on the ground as opposed to in microgravity. But I also like to say that when you compare that differential to the differential that we experienced by doing tests for our entry system for Mars, that's obviously a much more difficult problem.
So the first time you'll actually run it at the super cold temperatures all the way down will be on space station. And you've also had to take this technology and shrink it down into something that will fit on a rocket and survive ascent, mind you. So you've got this very complicated experiment that has to survive the rigors of going up to station, being in a microgravity environment, and then essentially for the very first time going all the way down to these super cold temperatures. Is there a moment, like is there a flip the switch kind of moment date that they've set for like a viewing party, right? You think Mars, right? There was the 7 minutes terror. Everyone got together. There were places all over the U.S. where you could flip it on. Is there going to be something? I mean, a little smaller because it doesn't have the same marketing back end, but something like that going on with this.
For sure. We haven't yet been manifested on a launch vehicle. So going up to space station is a lot easier than going to Mars because for Mars you have a planetary launch window, right? You can only launch basically every 2 years. So when you go up to space station, you can pretty much launch anytime as long as there's a rocket going up. So it'll probably go up in the fall of 2017, and then it takes only a few days to get up to space station. So certainly we'll all be ready and waiting in mission control to see when to help the astronauts with the installation process, which isn't too complicated, and then to see the first data as it comes down.
And Warp 11 actually
happened in the fall of 2017.
Yeah, this question relates directly to that. He asks when, fall of 2017, but also what launch vehicle are you flying on?
We're actually compatible with several. So we're compatible with SpaceX Falcon going on a Dragon capsule, and we're also compatible with Antares going inside of a Cygnus. So our unique constraint is that we will only go inside pressurized cargo vehicles. And so the Orbital has a pressurized vehicle. I think the Japanese has a pressurized vehicle, and then SpaceX has a pressurized vehicle. But right now, we're probably targeting a fall SpaceX launch of 2017.
And kind of along those same lines, Scooch from the chat room asks, were there any compromises you had to make for your experiment in order to put it on station?
Compromises. So in a sense, yes, but we going on the International Space Station actually facilitated our mission in a large way. And so the reason for that is because we're able to stay inside of space station. We're always able to be in a shirt sleeves environment. So Cal is essentially a very complex optomechanical system. What that means is you have optical elements and you have to have mechanical elements that ensure those optical elements remain aligned, both due to thermal changes, due to launch vehicle vibrations, as well as sort of material creep over time. So the fact that we're not seeing the temperature extremes and swings that you see in the vacuum of space, because we're always in a shirt sleeve environment, we're actually able to use a lot of existing commercial hardware. So that actually facilitated our mission and made the complexity associated with it was still very complicated, but it's easier than having to handle the temperature swings that you would see in the vacuum of space. So for example, one of the things that allowed us to make the instrument very small is that we use lasers which have fiber optic outputs as opposed to lasers which you basically have to have free space optics. So that allowed us to have a much smaller overall volume. And we can only use those fiber optic output lasers because we're in this shirt sleeves environment. So I wouldn't say it was a compromise, I would say it was actually a positive thing.
Lars von Braun asks, what do you want to do next when you're done with this?
So my next role is actually going to be working on exoplanets and the physics of the cosmos, because I'm a manager in the Astronomy and Physics Directorate. So there's a big push now to have another mission go up, which is going to look for exoplanets, and another mission to go up to understand sort of the physics of the universe, cosmic origins. So that's probably what I'll do next.
So looking for exoplanets is kind of broad. Anything specific? Are you looking for like planets in Goldilocks, or just what makes up the planets, or just something exoplanets related?
So for exoplanet detection and for physics of the cosmos detection, what you need is better sensors, so better detectors. And so a lot of the technology that goes into it is either related to the detectors, like CMOS detectors, or it's related to telescopes, and the telescopes that have mirrors inside of them or lenses inside of them. So it always comes down to an engineering limitation that you then have to push the envelope to be able to do something more. So we're talking about better resolution, higher contrast. So it's really related to being able to sense the starlight and be able to decipher more information out of the starlight. Or in some cases, trying to get rid of the starlight so that you can see the planet that sits in the background. But there's so many different opportunities at JPL that kind of the sky's the limit. So the other huge mission that we have going on right now, of course, is Europa. So I think there's going to be a landed element on Europa. So I probably would love to work on that as well. So it's so exciting because there are so many places that we haven't yet been that all of it requires new engineering designs to be able to get us there.
So last question before we go into our general 5 questions we ask everyone, which is, this one comes from Soul Whiskey, I believe it is. As a child, what inspired you to go into science? And what can you say to my kids to inspire them? They're watching right now. Ready, go.
So I am a science fiction fanatic. So when I was 6 years old, I watched rerun of Tom Baker, Doctor Who on public television, and I was hooked. So to me, the idea of traveling through the universe, being this incredibly intelligent person that knew everything about everything from medicine to engineering to science, that completely motivated me as a small kid saying, I want to be like that. I want to be the doctor from Doctor Who. I also watched reruns of Star Trek with my dad, and I absolutely loved Mr. Spock and how intelligent he was, and he was a science officer. And so the exploration into the unknown kind of motivated me ever since I was a small child. So I kind of always knew I wanted to be involved in the space program. I just didn't know whether I wanted to do astrophysics, astronomy, or engineering. And I ended up picking engineering because I love to build things. That's what's so amazing about engineering. So how could I inspire your kids? I think you have to follow your passion, whatever your passion is, but you also have to make sure that your kids are exposed to a whole range of disciplines so they can figure out what their passion is. And so I got lucky where I hit science fiction really early on, but if you give them that exposure to arts, to music, to science, to engineering, let them make the choice. Don't try and push down their throat things like Barbies or, I don't know, Care Bears and things like that, right? You want to make sure that they've got a full suite of understanding what it means they can be when they're older. And then for me, it's because I had this great exposure to science fiction. My dad was actually a mechanical engineer as well. And I had a brother. So I was always very exposed to a whole range of things that you could do as opposed to just what a lot of my female little friends would do, which would be playing Barbies.
Do you have a TARDIS, like a little miniature TARDIS on your desk by chance?
I don't. I actually had one that my friend 3D printed for me. That's even nerdier, and then I wore it as a necklace.
That's amazing. That's totally amazing. Now I think you need a full 3D printed TARDIS that just sits on your desk. I think that would be the ultimate nerdery.
I do have a Doctor Who scarf, and I do attend the Gallifrey 1 conference every year, and this year I gave a presentation on Cal and MSL.
All right. Yeah, all right.
I'm a nerd.
That's all sorts of fantastic. All right. Before we go into break, 5 general questions we ask all of our guests. No right or wrong answers. Go into as much or as little detail as you'd like. The first question is, should we send humans to the moon or Mars first?
So my opinion there is it's actually one related to technology. So I have a background actually in entry, descent, and landing systems for entering planetary atmospheres, and I'm actually teaching. I teach that at USC as well. I'm a professor there. So the technologies that you have to develop for landing on the moon are completely different from the technologies that you have to develop for landing on Mars. That's because the moon doesn't have an atmosphere. So on Mars, you don't need a parachute. Right? On Mars, all you need is retro rockets. And then because you're in a vacuum environment, the way those retro rockets perform is completely different. So from a technology perspective, I would rather see us go straight to Mars so we spend the money and the time and the political will to get us to that destination. Because the moon may deal with the human aspects, but another example is that the radiation environment on the moon is completely different from the radiation environment on Mars. As you get further away from the sun, you now have a larger component of your radiation which comes from galactic cosmic rays. When you're by the moon, all of your radiation comes from solar proton events from the sun. So you're still not even developing the right radiation protecting technologies. So I see much more advantage in going to Mars because it allows us to spend the money on the technologies needed to get us into deep space.
All right, that's a very thorough answer. All right. The next question is, would you go?
Yes. I would definitely go, but we still have a ways to go to get the technology right. And I would say from the radiation perspective is probably one of the biggest challenges. But yeah, I think it would be amazing. I think our future as a species, and this is a global effort, is to explore the universe, to explore our solar system.
Which leads directly into the next question quite well, which is when do you think humans will first land on Mars?
Unfortunately, it's largely related to funding. So if we could all work together, if all the different international space agencies could work together and pool their resources, I think it could happen in less than 30 years.
And when do you think humans will when do you think humans will set foot on the moon again?
It sounds as though there's private ventures associated with this, so that could happen a lot sooner in that sense. So perhaps in less than 10 years.
And my last question for you, why space?
Why space for me? Oh, because I love the unknown. And I think the one thing that drives all of us is understanding why we're here and how we came to be. And one of the most amazing things about working on Cold Atom Laboratory is getting this better understanding of atomic physics and realizing that we're all just made of subatomic particles. We're all recycled subatomic particles. Every time we eat a sandwich or an apple, eating a set of subatomic particles, which came from somewhere else. So ultimately, we're all stardust. And all of that now makes sense to me now. And I think it's beautiful.
I was waiting for it to slide into all made of stardust. All right, thank you so much for joining us. Where can people go for more information on the Cold Atom Laboratory and yourself?
So I'm on Twitter. So my Twitter handle is Dr_Astro. I'm also on Facebook. It's like facebook.com/Dr. Anita Sengupta. We have a website for Cold Atom Laboratory, which is coldatomlab.jpl.nasa.gov. And so, yeah, and if you Google me, you can find me relatively easily. But I always answer questions on my Facebook page or on my Twitter if you've got more questions specifically on Cal. And we're ultimately, I believe that NASA exists to motivate the next generation of kids to become scientists and engineers. So I'm here to help with that.
Well, I'm excited for you to have on your resume, created the coldest spot in the known universe. Not a lot of people are going to be able to say that is something that I've done. That's going to be absolutely incredible. Looking forward to it. All right, thank you so much for taking time out of your Saturday. Look forward to the experiment, hopefully flying later in 2017.
Thank you
All right,
for having me.
We're going to take a quick break, and when we come back, comments from last week's show. Stay tuned. We'll be right back. Audio? There we go. Awesome. Thank you so much. You don't have to stay for the rest of the show if you don't want to. It was a fantastic interview. Where am I? I'm over here now. It was great. I hope you had fun.
I did. Thanks for having me. I appreciate you giving us some airtime. So.
Oh, of course. Cool. It's you're creating the coldest spot in the known universe. Hard not to give you some airtime. That's really cool. Ha ha! Boom, boom. All right. Thank you.
Bye-bye.
Feel free to stay on, or you can hang up. We'll continue the show from here. Thank you.
Take care. Bye-bye.
All right, Dada. I just restart the Casper side, and then we'll just come back in from this element from the. Can I
leave the client open?
Yeah, you can leave the client open. You just need to restart the server. I wonder why that's happening. It could be, but that feels more Dante related. Hope everyone enjoyed that interview.
We've always looked to the stars. They guide us.
I have to edit it in anyhow, so we'll just come back up from here.
Who's opening this one?
I didn't open. You did. Jared, why don't you do this open?
Okay, sure.
Sorry.
Yeah, I could do it.
Ready?
Mm-hmm. And welcome back to Tomorrow. Now, before we get to our comments, we just want to thank all of our patrons of Tomorrow, starting off with the Escape Velocity variety, who give us $10 or more per episode. We also have our Orbital patrons who give us $5 or more per episode. But wait, there's more. We also have our suborbital patrons who give us $2.50 or more per episode. And in addition to that, we also have our ground support patrons. These folks give us $1 or more per episode. So if you would like to help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. Oh, that was a great interview.
That was,
Lots of science in that
so
interview.
interesting.
Science for the win!
I'm also really sad that there's so many puns about that was really cool, because that is not it's not something that I want to say. But it was very, very interesting.
The puns.
And it seemed like every chat room that I saw, which was
Quite a
few at this point, was very interesting. So that was very, very cool. I gotta come up with better words. My mom would be very mad at me. Anyway, so comments from last week's show. Last week, of course, Jared had an amazing interview with ULA CEO Tori Bruno. We gotta get Tori like a
Speaking of the Delta 4.
A hat with maybe the
mohawk
or something.
I know
we have a wig artist.
I know a girl that does wigs.
Yeah,
This
we
is
do.
true.
Yes.
I feel like, all right, here's
Aerodynamics for Tori.
Should we get him the same level of aerodynamics or what?
Maybe we could just get him a T-shirt that says something about head aerodynamicist.
All right, moving on.
Okay. Anyway,
Yes.
First comment comes off of YouTube. This is from the famed Chris Radcliffe. Hi, Chris. Chris Radcliffe, thank you. Says, Carrie makes a great point about Apollo's milestones at 6:10 in the show that have been glossed over with audible pedantry. Well, Apollo was the end result of more than a decade of hard work. The time between things starting to work and landing on the moon was very short. Well, really short. Announcements like the SpaceX Blue Origin moon missions are coming at us quick, but that's because space companies are finally getting to the place where they can do some really interesting stuff that they've been working on for a very long time. So exciting.
So, here's what happened. During the last show, we were going into news, and we were doing stuff, and Carrie Ann mentioned the very short time frame between Apollo 8 and Apollo 11.
Right, because it felt really short. I was like, dude,
And
that's crazy.
It was, but I got this look on my face of what? Because they happened in different years, and my brain got stuck on that they happened in different years. I'm like, no, they are years apart. They're not months apart. They're years apart. And then my brain was moving at super slow speeds, right? We had brought the temperature of my brain down, so it wasn't working very fast. And
it was Einstein-Bose condensate.
It was, and so you can if you go back and watch this show, you can actually watch me starting to do the math in my head of how, and then I'm like,
oh yeah.
They're still talking, and I'm sitting there going,
right, because Tim and I were like, yeah, no, that's totally a thing, right? And he's like, yeah, that's totally a thing. And I was like, cool, I'm not wrong, so we're just going to keep moving then, I guess.
And then we had moved on. By the time I'm like, oh yeah, no, she's right. So
That's a fantastic comment, but I actually led with it just so that Chris can call Ben pedantic.
Thanks, Dada. Thank you, Dada.
Yep.
That's fantastic.
Yeah.
So there's
That's why that happened. She was right. And that's why I had that look on my face, is because I was actually trying to figure out why what she was saying didn't match with what I had in my head. And that's because they were years apart, but still only months apart.
It's twofold. What happened was Carrie Ann was right, and Ben was trying to figure out why Ben was wrong.
Ben wasn't wrong.
Ben wasn't wrong.
Let's move
he was
on.
Very wrong.
No, rule number 5. Let's move on. I don't like this. I don't like that comment anymore.
Doesn't
I don't like that
exist.
comment anymore.
Next comment comes off of Patreon from William Trader. Good interview with Tori Bruno, but his Skype setup royally sucked. Sorry. Someone needs to tell Bruno to get a better microphone, better webcam, and better internet connection.
So I think the microphone's my fault because I did notice it scratching in advance, and we kind of had him move it, but I should have had him clip it, and I didn't think to do that.
Yeah.
The microphone I think actually worked well. The microphone wasn't bad. It's just that it was rubbing against his collar. That's on us for not letting him know. And yeah, I mean, the call is the luck of the draw, right? Bandwidth providers in the U.S. are not super awesome. I don't think that's really Tori's fault.
No.
I mean, it will.
Also,
frankly, I'll take a bad connection with Tori over no connection with Tori.
Right, exactly. I think, in general, CEOs of relatively large aerospace companies don't typically call cute little video podcasts in order to do an interview. So, I think it's ever so slightly excusable, and we'll work with him in the future for the next time that he's on.
That is not the first
to improve that.
That's not the first or last time that's going to happen. That is the nature of the beast.
Yeah.
This is a live show. It's gonna happen. Sorry.
Welcome to live shows.
What we do is we make a real-time decision. Can you understand what's going on and being said? And if the answer is yes, we continue with the interview. And maybe we're struggling a little bit. In like 90% of the interview was just fine, and then that last 10% struggled to hear a little bit because the connection was dropping out. If you can no longer understand it, if it drops to a point where it's completely unusable, we do actually stop the interview, try to roll it back, and try to work on the tech. But in general, we want to keep the show flow going, right? I mean, we want to make sure that conversation keeps continuing. We want to make sure that we get your questions out there. I thought the coolest part of that show is I was frantically typing the questions and popping them up on screen. I'm eager to get that going for the regular show. So, all right,
next comment comes off of Facebook, actually. This one comes from Thomas Muscarella, I'm going to say. This interview was awesome. It was. I was 7 years old when I saw the moon landing on TV. Back then, I remember being so excited about the future, but all that seems to go away as people lost interest in space. Today, I feel like that 7-year-old again. ULA CEO Tori Bruno gave me back my dream of one day going into space. You don't know how awesome this interview was for me. Thanks so much.
Oh, that's fantastic.
Yeah, you're welcome.
I'm glad that's why we're here. We're here to get humanity inspired about exploring the cosmos.
Totally.
That's what we do. So I'm glad that we helped. In fact, now that we've helped, we're done. So we did it.
We reached our one person.
We did it.
Yay! Oh goodness.
All right, have a good one.
Lights out now. How sad would that be? No, I actually had a great conversation in the Twitch chat room, talking a little bit about some science and spacey things, and I said honestly, I think since starting the show, after seeing kind of the state that people have sort of lost that 7-year-old kind of glint in their eye, that I'm more dedicated to doing the show than I was when we first started. Does that make sense?
Yes, it does.
Good conversations going on all over the place. Okay, so this comment comes off of Twitter, actually, coming from all over the place, from Trini KP. At Tomorrow at Tori Bruno, incredible interview. Great info and content. I really like the approach ULA is taking towards building a space economy.
I do too. I think it's pretty cool.
Yeah.
And what's great is that we've got all of these companies doing something different, right? We've got SpaceX doing one thing, Blue Origin doing a totally different thing. We've got ULA doing yet another totally different thing. We've got Virgin Galactic doing a totally different thing, right? So it's really cool. Not all of these are going to stick.
Right.
In fact, I would estimate well over 50% will not. But there are so many of them now that I firmly believe at least one of them will. I don't know which one, but I'm excited. I'm excited to follow along with everyone else and see what actually sticks.
Yeah. The more players you have, the more likely success is. So
absolutely.
That's what's so exciting about it.
Wall of text.
Well, yeah, yes. Next comment comes off of Reddit.
Bingo!
It's a little wordy, but it's okay. It's from Mr. Macabar saying, I used to think that ULA was just a monopoly on U.S. government launches, which did not care about anything but making money. After SpaceX grew to be a serious competition, I just presumed they hired a nice CEO as a public face and drew up some cool plans. They did not look like conservative, so they would get at least some political support. But after watching this, I honestly believe that they are serious about changing the industry and their amazing plans, which makes me excited to no end.
Yeah, I hope so too.
Yeah.
Yeah, right?
There are two parts of it, right? There's the talking about it and doing it. And the thing with aerospace is that you have to talk about it for a while, and then there's a whole lot of behind-the-scenes work that no one really gets to see.
Yeah.
It just happens, and it takes a really long time. Years and years and years. And most of these companies have been laying out that groundwork. I think Blue Origin is a really great example of, like, they've been around for over a decade now?
17 years.
Yeah.
17 years.
Yeah, it's
They've been around for nearly 2 decades.
Yeah.
Nearly 2 decades. We're just now really getting to see the fruits of that labor. But now that they've gotten it there, it's just coming out, as I think Chris Radcliffe mentioned earlier, they're just coming out really, really fast. It looks like it's happening really quickly, but that's because of all of that work that they've done over the last nearly 2 decades. That's just one example.
Yeah, no, exactly. all of that stuff. Okay, so last comment comes off of YouTube. This is from J. Michael. I have never said your last name before in my life. Antoniewicz. J. Michael, you will forgive me. I apologize. The second, yes. Goodness. That has to be in there. So, working with Roush Performance Engines to produce an internal combustion engine that is key for the ACES system, well, they just picked up the largest sports fan base in the USA, NASCAR, who will take note of ULA, ACES, and CIS Lunar 1000.
I don't think I tracked that one.
Roush produces engines for NASCAR. So if you're doing Roush Performance Engines,
got it.
I like that they're called Roush Performance Engines, by the way, for the ACES system. Then I mean, who's not on board, right?
Yeah, should be
you
good.
You still have to make right turns when you go into orbit or left turns.
It's left turns with NASCAR.
I know it's left turns with NASCAR. So. Is it left turns with rockets too?
It's gravity turns.
Oh, gravity turns.
Which are all left. So there you go.
There you go.
There you go. Same kind of turn, so we're good.
Just kidding.
That was pretty cool.
Kidding. All right. Goodness gracious. Benjamin James, who do we have on next week?
We have Jose Lopez. Oh, man.
Boy, did you botch that one.
Should have practiced that before the show. Zero to Infinity. Thanks. That's great. That's why you're Capcom.
I know.
Zero to Infinity. They're doing high altitude balloons, but then also launching platforms from those balloons to continue off into space. That's going to be a pretty interesting interview,
right?
which one of you two will be taking because I won't be here. And as a reminder, if you're one of those time zones in the U.S. that changes your clocks, Showtime is changing for you as well. So head on over to TMRO.tv/live, and it'll be a little countdown clock kind of thing telling you when it's going to go. All right, on that note, I'd like to thank everyone's... Well, that's how it's going to work.
I mean, it just is.
Nah.
It's going to be a thing now.
It'll be a thing. I'd like to thank everyone so much for watching. After Dark is up next. See you next week. Not a countdown clock thingy, saying in the chat room. God. I liked having, so the tomorrow, you guys, y'all, have a slightly different chat interface than we do. We have buttons and levers and dials that we can use to moderate stuff. And for the first time, when we were broadcasting on Twitch, by the way, hello to everyone on Twitch.
Hi, Twitch.
We were actually able to suck the Twitch chat room directly into our interface. It's not quite the way it's supposed to be during a regular show. It actually got dropped into another tab, and we had to manage multiple rooms. But it was pretty cool to actually be able to see that interface working. I'm excited. Actually, I think a couple Twitch questions made it into the show.
Yeah, yes, a couple of them. I think Jannar, got one of the questions on air, and then Rebel Ace Frisian. I'm probably pronouncing that incorrectly. I apologize. But Rebel got at least one question on.
Cool.
Yeah.
So. Testing it out. As Mini Soch says, hi Twitch, this is our show after the show, After Dark, so very, very, much more casual, just kind of...
We just hang out.
Just hanging. Just talking.
We're just chilling with each other.
So looking to see how all of that's going to go. And then I'm excited for when the chat room will also be able to pull YouTube chat, Facebook chat, Twitch chat, all into one central location via our chat room. And then we'll be able to see where the comments are coming from, no matter where we broadcast from, ask them out on air, have all of that moderated, and then eventually those questions, like those graphics that you saw last week with the question on them, that's the end goal, right? So we want to be able to have the chat room automatically generate those. They pop up on screen, so when you ask your question, boom, shows up on screen. It's going to be awesome. Vax asks, why isn't there a UTC clock on the website? There used to be. It gets tricksy a little bit. Ultimately though, the live stream itself counts down to the event, right? So the YouTube embed has a countdown clock that says, hey, this many more hours and minutes until the event starts, and it's counting down to the exact time of the event. So that's generally good enough for me.
Yeah.
Someone said, thank you, I think it was Minisoj, thank you for saving the interview. I don't feel like the interview ever got off track. We did start getting really technical, and then I felt like we were getting too technical, so I actually kind of backpedaled it to, all right, let's talk humans for a minute. But I mean, it is, what we're doing is really technical. Well, what we are doing, what they're doing is really technical, and it's
hardcore.
It is hardcore, but I think it's okay to have a technical show once in a while. We don't have to.
But I think she was also fantastic in being able to, I mean, for lack of a better term, dumb it down so that normal peasants like us can understand what these physicists.
She turned quantum mechanics and made it relatable.
Yeah, exactly. I don't feel like
awesome.
I didn't really understand what she was talking about.
Yeah,
I felt like our audience base, for the most part, would be right there. Correct me if I'm wrong. I mean, if I let her get too technical, certainly let me know. But I felt like we weren't. We were dancing that line.
Yes, but it was super technical. But she was like making it understandable. It was great.
Yeah, I thought so too. I liked it.
Yeah, the plain speaking was nice.
It was pretty cool.
Chris Radcliffe says the YouTube countdown shows days to me. It shows you days until the day of. Once you get underneath 24 hours, it should convert to hours and minutes. Well, actually, it'll convert to hours, and then once you're under an hour, I believe it converts to minutes. Yeah, I thought, yeah, as Chris Radcliffe said, she was getting technical, but the good kind of technical. I agree with that. So I didn't feel like there was any. All I did was I took the interview and I shifted its direction because we got the technical conversation. And I was like, all right, well, now tell me about the people. Tell me about you. Tell me about, you're doing all of these incredible things. Tell me how all of that goes. Yeah.
We still have to do an open.
Yeah, we do. Wanted more, only getting a taste. Yeah, I mean, at the end of the day, that's kind of that's the nasty little part of tomorrow is that we're not going to go for 2 hours. We can't. Remember, it costs us money to make the episodes this long, and the longer we make them, the more it costs us. So 2 hours is not a thing. So we kind of leave you wanting more, and that's why we always say, hey, where can you go for more information? And then if you really are interested in the subject, you should go there for more information. You should absolutely check out the Cold Atom Lab. And we'll certainly follow this up with when they launch and when they turn on the experiment. And hope maybe we'll do some sort of cool live stream when they turn it. If there's any data that we can get back in real time, that'd be kind of cool.
Yeah.
That'd be no dying.
Jarnar says, I don't mind technical shows. Do more of them in the future. So, some are, some aren't. We're trying to appeal to a wide variety of people. And some people like the technical shows and some people don't.
Yeah, not every show is going to be a technical show.
That's fine.
Some of them will, some of them won't. It all depends on the guest and what we're talking about. This one deserved to be a technical show. It should have been. But like I said, I thought it worked well. I thought it was just technical enough to keep the nerds happy and then not upset the non-nerds. I don't know because we're trying to inspire everyone to get excited about space, and some people are just starting, right? Some people just do not know, and that's okay. If you don't understand the terminology, but you're willing to say, hey, I don't understand the terminology, we're more than happy to explain stuff, right, and help educate you because wanting more. There's nothing wrong with wanting more information. Saying I don't know is totally valid. Anyhow, all right, we need to do an open, as you mentioned. Let's see here. I'll say the NASA authorization bill passes. Jared, what was your favorite story?
Blue Origin's new rocket.
Okay. And then you'll say, plus an interview, something. Sorry.
It's really annoying.
Or more info on New Glenn. Guess that would work a bit better.
Okay. And then you'll talk about the interview for me?
Yes, I will talk about the interview for you.
All right, cool. All right, here we go. I'll start, Jared Carrion, and then you'll take us into the intro. Here's number one. Coming up, the NASA authorization bill for 2017.
More info on New Glenn.
All that comments from last week's show, but on this one, I apparently don't know what I'm saying. One more time.
Stay tuned. Right. Tomorrow begins right now.
Cut, break, wrap.
That's good.
It's all right. It's all good.
It's like I've never done this before.
And for those of you watching on Twitch for the first time, this is normal for us. All right, number two. Try number 2. Here we go. Coming up, NASA's authorization bill for 2017.
More info on New Glenn.
All that and more. I don't know. Oh my God, what is happening right now?
It's all good. It's all good.
That's amazing.
We're fine.
That's amazing.
We're fine here.
Tomorrow begins right now.
That's right. Ben turned into like 40s radio announcer.
And stop.
NASA's authorization. I can't even do it. NASA's authorization bill for 2017.
Those young kids sure do enjoy their NASA. You get 'em, whippersnapper. That's all right, Sally. You'll get it right next time.
Oh, don't.
Don't make me hurt you on here.
New info on New Glenn. Seatbelts.
I'm sorry. I'm really sorry. All right. 3.
All right, number three. Here we go. Coming up. You can't be making that noise. It's going to be a weird intro. All right, here we go. Still number 3. Train.
I can't hear anything.
I'm sure no one can either, but I'm going to wait anyhow. Makes for a good awkward moment. Is it still going? All right, doesn't matter. All right, 4. We're going to call that 4. Here we go. Coming up, NASA's authorization bill for 2017.
New info on New Glenn.
And Ben has a great interview with Dr. Anita Sengupta from NASA's JPL's Cold Atom Lab. All that and more coming up on this episode of Tomorrow.
Print it! Woo! Woo! Monorail. Rebel. Wow. So I tried to say Rebel's name. Rebel on Twitch. I only referred to you as Rebel because I realized pre-show I referred to you as Rebecca, and I didn't want to make it even worse. So it's Rebel Ace Fries Land.
No, it's Friesland or Friesland.
Rebel Ace Friesland.
That's a part of Germany, right?
I had to look it up because I wasn't familiar, right? It's Netherlands. Friesland.
Rebel Ace Friesland.
Yeah, see?
Cool.
Copy. All right. So, hello, Rebel. I actually can't see how many users we have on the Twitch side.
7.
No, that's not correct.
User list says 7.
Right. That's incorrect, though. That's not how many we...
Yeah.
Right?
Yeah, it's way wrong. Yeah.
Dada's like, 7! The number is 7!
And the number of counting shall be 7.
Let's see if we can see it over here.
Friesland.
Woo!
Friesland.
That's incorrect.
Boop. See?
Oh, we have over 100 people watching.
Yeah.
I think. Or no, 25 that are watching right now.
We got 25 right now. That's not bad. I mean, so hello, Twitch.
Hi, Twitch.
We're not announcing
Friesland.
that we're there.
Yeah, we didn't really say anything about Twitch. At pre-show, we kind of sort of mentioned it. Again, we're just testing right now.
That's cool.
Just checking it out. Seeing. Well, Twitch is a very large and vibrant live community. So I'm not super surprised that there are, there are 27 people now. Yeah. So, by the way, if you're on Twitch, we're going to continue testing for the foreseeable future. You see how this works. I can report a playback issue. That isn't what I want, though. Neat. How neat is that? That's pretty neat. I can't change my video quality, though. Off. Back.
Western Frisia is in the Netherlands.
Anyhow, there you go.
Yeah, so I learned something new today.
Cool. Boop. Interesting.
Quite.
No, I did. So Colton is asking why transcoding is off. I did not enable stream delay beta, so I have no idea why it's not transcoding in Twitch. No clue what's going on there. And Dutta's chortling at what?
25 on Twitch. 25 on Twitch, 116 here, which is our Tomorrow TV chat.
Yep.
If my math is correct, that's like 1 million people, says Little Blind Crippled Girl.
Pretty much, yeah.
So, Little Blind Crippled Girl, that is a difficult name for me to say when you post a question to a guest.
A little blind crippled girl asks.
Right. No matter what the actual motivation behind it is, when you say that to someone who's not expecting it, it can almost sound insulting. So, I asked one of your questions on air, but I chose not to use your username. I just want you to know that will likely be an ongoing thing. I don't mind the questions, but saying the username is exceedingly difficult because I don't know how their guest is going to take it. Maybe they won't care, maybe they will care, but I can't risk it. So, if you want your username mentioned, changing it to an acronym, LBCG.
Yeah, LBC. Yeah, she said LBCG is fine.
Yeah, so that, sure, but I would recommend you change it chat side because I'm not going to, I'm going to see it and I'm not going to have the mental, trying to do those
You can
interviews.
still say just Little Blind, though.
Little girl.
Little girl?
Little girl wants to know.
That's creepy, is what that is.
Little girl wants to know.
Yeah, I have to say it in that voice, too.
But, like, in poker, sometimes there's a little blind and a big, big blind.
Yeah, no, I get it. Gaming name, that's cool. It's cool. You're free to use it. You can do whatever you want. I'm just letting you know that during the show, if I ask you, if I have one of your questions, I will ask your question if it's a good question. I did today, I believe, but I will not say your username, just because it does create a weird moment between me and the guest, and it doesn't make sense. So, I just want you to know. It's not a disrespect thing. I wanted to convey that.
That also goes for comments. We either censor the username or don't use it.
Yeah. I mean, we look at the message as a whole for comments. So, if it's a really good comment but a terrible username, we'll still post it. But as Dutta said, we'll censor the username. But in general,
Although sometimes we miss.
That happened. Well, that happened once. I think we're a little more diligent now.
Yes.
Yep.
Also with your avatars.
Oh yeah, avatars count too. All of it. It's your entire account.
Yeah.
All right, cool. I just wanted to get that out there. I will also say, I think I already said this, having the Twitch chat in here is all sorts of awesome, and being able to push those questions made me super happy. I've been debating, as Carrie-Ann will tell you, although I don't think I've had this debate as much in the chat room or in Slack, been debating, all right, what makes the most sense? Do we broadcast on YouTube, Facebook, and Twitch, and then work to suck all of those things down, which creates a fractured community, right? So if you're talking on Facebook, and even though your comments make it to us, you can still only see the comments that are on Facebook, right? That's the only conversation you can see. If you're watching on YouTube, and you're only watching on YouTube and chatting on YouTube, you can only see YouTube comments. Again, they'll eventually still make it to us. So is it worth fracturing the community? And I think that might actually end up being okay. I think having different conversations will be fine. Open to thoughts. If you have strong feelings, Benjamin at TMRO.tv. So what were you doing this morning? News crew, or what was the?
The city of Lakewood has their own production, like their own TV channel. And they're covering kids basketball championships.
So they're cooler than us, and they get donuts.
Yeah, they do get donuts because it's 7 a.m. crew call. That's like early.
Hey,
so you're cheating on Downey too?
What?
What I'm saying?
The city that puts you on their newspaper as people to follow.
I don't understand. What am I being accused of here?
Not bringing us
First
donuts,
of all,
you're being
man.
accused.
I want donuts.
Not bringing us
We want
donuts, man.
Jared.
I can bring donuts if you want me to bring donuts.
We want you to want to bring donuts, Jared.
Why would I want to bring you donuts?
What is my motivation here?
CPU 2K6, how come a longer show costs more? It's hosting charges, right? So in order to get the show into iTunes, it doesn't have to cost more. We can make it not available on iTunes or Roku and then it will not cost us any more, and we won't have to pay for every download that occurs. Otherwise, the longer the show, the larger the file, the more expensive the download becomes. Oh yeah, there's a Twitch app too.
Yeah, Rebel Ace and Jarnar are talking. Is it Deutsch or the Denmarkian Deutsch? But I can speak Danish too, although not Frisian, even though I live in Northern Frisia, which is kind of awesome.
So someone in the chat room is saying, but I come here for the chat. I want to be able to see all the chat. That will remain. So the end goal, while the hosts right now have a test room for Twitch in our own chat room, the end result will be you'll be able to link all your social accounts, and you'll be able to turn on and turn off all the remote chat rooms in as well. So eventually, as things start to roll out, in the main chat room at tmro.tv/live, you'll be able to go, I want to see just this room. I want to see this room and YouTube. I want to see this room and YouTube and Twitch and Facebook and in Twitter and all of the things. So you'll be able to turn it on or off from one interface right on our own page. So if that's the experience you like, cool. I've also asked Colton, or if you're a programmer, I would love your help. Actually, I want to get our chat room bigger and on the right-hand side, going kind of all the way up and down, and then size up the video window, but maintain our header and maintain the header in such a way that we can continue to do updates to it, so we don't have to rebuild it from scratch every time. So, would love a programmer person that can help us make that happen. Benjamin at TMRO.tv.
Wow. Rebel Ace Frisian says, I can speak Frisian, German, English, Dutch. Danish I can understand a bit because of its closeness to Frisian. Frisian. I barely speak English on a good day.
Yeah, no kidding. Me too. DanTC24, what's the story behind modding, like missing the inappropriate username?
So, the story behind it, there was like one show where...
There's recent, too.
It wasn't even like one comment. It was like two commenters in a row had like... Well, I can't say anything that's inappropriate, but,
But it's after dark.
Yeah.
I guess. But it was like, you know how when you have a long username, right? And so sometimes it comes off as, Mrs. Schlongerverse. And you're like, what does that say? You're like, oh, it's Mr. Schlongerverse. Like, fantastic. That's a great username. Like, I can't say that on air, you guys.
I think I remember that.
Right, but it wasn't just one. It was like two of them.
There were two,
and it was like, and the whole episode was like that. It was so like when Ben wasn't here.
Yeah, I wasn't here. And she was turning beet red on camera.
I was, and
because she's having to read these usernames, and she's like,
well, because silly me, I was only reading the comments. I wasn't reading, Mr. Schlongerverse, and I was like, dude, you've got to be kidding me on this one.
Mr. Schlongerverse.
Well, I couldn't think of anything that sounded somewhat appropriate and
I
somewhat not
enjoy
appropriate.
Mr. Schlongerverse. I think that's all sorts of magical.
Yeah, never mind.
I have to apologize for that because I'm the one that actually grabbed the comment.
It's fine. It ended up to be okay, but it was like, oh.
And I put you in a spot, so
way to go, Dada.
I don't want to do that anymore.
It's okay.
I'm sorry.
But so that's the story, and so now as it goes, if your username is Mr. Schlongerverse, I probably am not going to say that. I'm probably going to say this comment comes off of YouTube. And so microgravity helps extend the test duration. Like, I'm not even going to, like...
So you no longer just read the prompter.
Yeah.
Well, I'm Ron...
Q San Diego?
I'm Ron Burgundy. All right. So I am going to... I was trying to decide if I should talk about the shows... I think I'm going to. I think I'm going to start teasing them now.
You're going to do that now?
Yeah, I'll start teasing them now, and then I'll go into more details in... All right, so here's what we got. First off, there are additions to the set that Dada hasn't finished yet. So we need to take a break on April 8th, which is the first time we have a show without a guest scheduled, which is why we're choosing April 8th. So, April 8th, there will be no regular Tomorrow Space show. In its stead, we will be doing our Patreon Hangout. So... We'll have Dada working behind us. Sawing. That's what that.
I'll be working too.
Yeah.
I'd be using my muscles.
We'll be doing that, and we'll be going into more detail on other shows that we are actively working on, such as we'll start with Tomorrow Cities. I'll be talking a little bit about what that is. I believe we are working to premiere that on April 15th. So Tomorrow Cities will happen right after Tomorrow Space. What we're going to do is we're going to do Tomorrow Space, finish the show, do our intro really quick so that we've got it, and then immediately go into Tomorrow Cities.
Well, really
finish
quick
that,
is so relative, as you've seen.
Well, no, I think we'll actually be quick because we'll have to be. Finish the show, do the intros. It'll literally just be us like, okay, intro, out. Go into Tomorrow Cities, do that show, then we'll go into After Dark. And then that's April 15th. And then November, Stoge, can I commit you to that date? I'm going to wait for Stoge to answer because I had a date. November-ish, how about that? We're planning on, that's up for debate, we're planning on adding Tomorrow Science also. So this year you should see 2 additional shows. And then these are pilots, so frankly, we don't know, right? So we're trying them out. We're going to see if we like them. We're going to solicit your feedback, see what you want, and go from there.
November 18th is what she suggests.
I know. I just don't know how solidified that actually is. So, so Tomorrow Cities, yeah, and I'm going to talk more about that in the April 8th show, like a lot more of what you can expect and show you some of the graphic elements. All of the shows will be, they'll coordinate with each other, but they'll be their own independent entities. We're also working on, hang on, I have my pretty graphics and that gives me all the different shows. Oh, that's good that that's happening. Yeah, thank you.
I think it's coming in from downstairs. The door doesn't work.
Yeah.
Well, I lost it. Anyhow, Tomorrow Tech, Tomorrow Science, Tomorrow Cities, possibly Tomorrow Transit, although I'm not sure if Transit and Cities will be one show. They might be. Tomorrow Space, and Tomorrow Oceans eventually. Now, the Oceans show I think is going to be the most fun. Also requires the largest budget. I actually want us to get one of those personal submarines that can go 400 feet down, which is like, 200 meters or something like that, and actually do live webcasts from the ocean with a marine biologist on board. Yeah, that's
cool.
Yeah, like how Jared's like, what?
I was like, what are you talking about, Tomorrow Oceans? Like,
no, really. That's the thing I actually
I realize
do.
that's a very big subject that there's a lot of stuff you could cover in it, but that's very specific to make it Tomorrow Oceans. That sounds really cool.
I think it'd be awesome. I think it'd be really cool to actually, and have so you're watching the marine life live in this submarine, and then
who's piloting the submarine?
We'll have me, of course. Dude, I want to be a submarine pilot. That's gonna dive. Oh my God, that's gonna be in the open too.
Don't you need to have your captain's license for that?
And you don't need a captain's license, but you do need a captain's hat. Yeah. It's going to be a thing.
My brother had to get a license to drive his sailboat.
Will the submarine be yellow?
I think you need to look into that.
So legitimately, I am trying to figure out how to make that go. Right now, a new submarine of that class that'll hold 3 people that can go 200 meters down is $1.5 million. Obviously out of our budget, but
for now, not
out of the realm of possibility. / maybe find a used one that's only slightly leaky.
I will never do Tomorrow MDF. No Green Gym 2. No.
That's amazing. That's amazing.
Get James Cameron as our first guest.
James. Anyhow, I think it'd be a lot of fun. Obviously, Tomorrow Oceans is years away. But I do want to push forward with the other ones. Mini Stoge Dickon for mid to late November. Yes, that's what we're targeting for Tomorrow Science. I'm excited for that. I think it's going to be a lot of fun. Tomorrow Cities will not be based in Anaheim, so it's going to be interesting. Yeah. Anyhow, For more information, Patreon Hangout, April 8th. We'll kind of start teasing. I think you'll start seeing a commercial for some of this stuff soon-ish, right? I mean, April's right around the corner, so yeah. All right.
Yeah.
Oh yeah, Copenhagen Suborbitals had a mini sub. What we need to do is figure out how deep it can go, if it has any windows, and if we can just have it. Be like, hey guys, can we have your sub?
Can we just have it?
Can we borrow it?
Yeah, for
long
like
term.
Long term, yeah, extended loan.
Can we lease
Sure,
your
as long as you
submarine?
go to Copenhagen.
And drive it back?
Yep.
That'd be amazing.
You're going to be without your husband for 7 weeks.
It's fine.
Or longer.
Possibly more.
I'm going to get lost. Actually, no, it's the middle of the ocean. That's the only place I know where I am.
So it doesn't make any sense.
I still want to see how you're going to broadcast from underwater. Just have like a little antenna.
Ask Reddit.
Oh, we do need to name it the Nautilus. Ask Reddit.
Ask Reddit how to broadcast from underwater. I'm sure they have great ideas.
Oh my god. You just need to drag a buoy behind you and hit a satellite with a really long Ethernet cable, and then maybe a.
Well, when I was in the Navy.
You sound like you've got some personal experience, Brian.
Yes, Vax. Big problem with underwater is the bandwidth. But there are indeed ways around that. We just have to be smart.
There are ways.
Does that mean we can have George back on?
George. Oh yeah, George. Well, yeah. Not Whiteside's. Schellinger, yeah. Everyone's stuck on oceans. I think it will be awesome once we get Tomorrow Oceans going, because then I will have had the two shows I was debating about creating at the start of all this. I'll have them both, and then I won't know what to do with myself after that. I'll be like, oh, all my life goals have been met.
You're done.
I'm done. I'm out.
You've peaked.
You just do what you did last time when you met all your life goals.
that did happen. Had to set the bar slightly higher. Are we stalling here?
Yeah, I believe we are.
My head is exploding.
Oh well, we need to stop then. All right, I think that's our show, everyone. I hope you guys had fun. Thank you, everyone on Twitch that joined us. Hopefully, you guys enjoyed it. All 23 of you. Mike, actually, a question before.
Well, we did have some people migrate from regular Tomorrow chat over to Twitch in order to have a more substantial Twitch presence.
And actually, that is my question for you, those of you on Twitch, which is, how many of you organically found the show and are not normally part of Tomorrow? And how many of you are part of Tomorrow and just kind of went over to Twitch because that's your preferred platform?
And how the hell did you find us?
It's not my preferred platform, but I went to hang out in the Twitch chat room, which I think I'll probably just continue to do in general. I'll try to bounce back and forth so I can kind of, because I'm not trying to ignore the other.
You can break your window into two, right? So you can see both.
Yeah. Just in general.
Yeah.
I think it worked out pretty well though, because then Kitty was in main chat. Stoge was kind of back and forth a little bit. I was mostly in Twitch.
What happens if I? Hello. If I type in here.
Yeah.
Oh, it pushes. Oh, that's not good.
It what?
It does say what I said, but it does it through TARS. Also, TARS is bright green.
Yeah.
So yeah. All right. So that's our show. Thank you everyone so much for watching. And I will not be here next week, but these two will. So see you in a week.
See ya.